This time, let's proceed to the hyperbolic functions of complex numbers. Now we have here the hyperbolic function for sine, cosine, and tangent. We are going to provide here the equivalent forms and later on use them as we prove also equivalent identities for hyperbolic functions of complex numbers. Let's start with our sine. Okay, hyperbolic function of sine z. Okay, its equivalent is of course a rational function similar to the trigonometric function, but this time it is in this form: e to the power of z minus e to the power of minus z all over 2. This is the equivalence for the hyperbolic sine function for complex numbers. Now, for our cosine, or specifically the hyperbolic function for cosine z, is given as another function equivalent to e to the power of z plus e to the power of negative z all over 2. The only difference is that for our hyperbolic sine function, we are going to use here the difference of the two terms, but for our hyperbolic cosine, it's actually plus. Of course, the last one, or for this video, is the tangent, or the hyperbolic function for tangent of z. Take note, we know this to be the ratio of the hyperbolic function for sine and a hyperbolic function for cosine. That means it's just the ratio of the two as well. Before I will give you the final form, let me derive it here so that you would be able to appreciate the final form. All over 2, that's for our sine. For our cosine, it's actually plus e to the power of negative z all over 2. Using the division of rational functions, or you use here the keep change flip method, you will have this form. Let me write it here at the bottom, and I'll be using this portion here. Probably because I might be using here, yeah, 2 colors. But anyway, for our first, we're going to keep this as it is. So you will have here e to the power of z minus e to the power of negative z all over 2. Okay, then you are going to multiply, okay, times, okay, times the reciprocal of our denominator. You will have here 2 over, so you have e to the power of z plus e to the power of negative z. Okay, that is why you are going to cancel this one here, and the final form for the hyperbolic function for tangent z, okay, is equal to the ratio of e to the power of z minus e to the power of negative z all over e to the power of z plus e to the power of negative z. These are the 3 equivalent forms for the first 3 hyperbolic functions for complex numbers. We have here the equivalent form for the hyperbolic function for tangent z. We already have here the cosine, and for the sine z as well. We will have the next 3 on the next video. Thank you very much for watching.